Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right. Well, today we have with us another person from Australia. So this is
and from your past.
And from my past.
Yes.
But we had Rod Johnson last week from Australia, and now we have Christopher Hunt from Australia. Where in Australia are you, Christopher? And welcome,
just south of Sydney on the coast, a little place called Bulli, which is like very nice surfing and stuff. Yeah.
But it's wintertime there currently, so we're enjoying summertime in Crested Butte, and I don't know what you do in wintertime in Australia. And
go skiing.
Yeah, you go up to the mountains.
Yeah, I've been to the mountains twice already, and
nice.
We managed to time it really, really well. Like we went in July, and you normally don't get very good snow for us, in terms of our conditions in July.
And we get terrible snow in July here.
Right,
but it was good.
But hey, you get snow in July, right?
Sometimes
it'll happen sometimes.
Yeah.
Actually,
so the snow was good though. The skiing was good.
The skiing actually was really, really good. And I have to sort of qualify that for like Australian conditions and so forth. But it really actually was very, very good, and nice. Really enjoyed ourselves. And it's obviously it's also about getting together with family, and my kids are kind of everywhere now, as we kind of just discussed, and so. It's really just getting together and hanging out and doing that kind of stuff. But I do want to bring something up.
Yes.
I did listen to the podcast. In fact, I've been listening to quite a lot of your podcasts.
Oh, thank you.
Yeah, no, they're great. And I'm feeling a little intimidated. You've had some pretty amazing people on here talking about
you are amazing, Christopher, which I'll do a proper introduction here in a minute. But
no. But anyway, so I was listening there to Rod, and you guys were talking about, hey, Rod, you must come over to Crested Butte again, do some skiing. And you said it's all steep and stuff, right? And I'm thinking, I've always wanted to go to Crested Butte, obviously to see you guys, but because of the attraction of skiing and so forth. And James, do you remember when we went to Overnaw?
I was just thinking of Overnass and the ski day that we had in Overnass. It was my last day ever of snowboarding because it was the best day you could possibly ever have. And so I was just like, I've reached the peak. And so that's when I switched from snowboarding to skiing. I'm like, okay, time for a new challenge because snowboarding will never be better than the day that we skied together in Overnass in Switzerland.
There you go. Didn't know that it was such a momentous occasion.
Oh, it was amazing. I mean, do you remember? So what happened was there was this whole off-piste area of the ski area that no one was skiing, and there was like 2 feet of fresh powder on it, and we just traversed over. And when we first started, we would take this T-bar up, we'd traverse over just a little ways, ski down first tracks, all of us first tracks. We did it again, ski over just a little bit further, ski down first tracks. And we did this for hours, just all of us getting first tracks in this giant bowl. And it was just the most amazing thing ever. We just kept going, kept doing laps on this until the ski area closed. It was exceptional.
It was an amazing place, wasn't it? We should mention also Overnaar is in Switzerland, and we were there because we at TypeSafe had the Lausanne office, which everyone wanted to go to for obvious reasons. But I, at that point, that was my first visit there, and I had not skied for 11 years, right? And, I would say certainly, of course, our mountains are not very high here and don't seem to be as steep, right? Or maybe not as long. And so not being on skis and then doing it, with an 11-year distance between the last time and then skiing in Switzerland is like being in free fall. And so what I want to ask you is Crested Butte worse than that?
Crested Butte has a variety of terrain, but there is much of it that is significantly steeper and worse than Overnass. Yeah, Overnass would be kind of the easy stuff on Crested Butte.
Okay, I might come there in summertime then.
Yeah.
Oh,
the mountain biking is amazing in the summertime. So, yeah. So, so I should give a little bit of background. So Christopher and I worked together at TypeSafe. We we had a lot, like a year or so, we worked together and actually built products together and worked on the Play Framework stuff together and really enjoyed working with Christopher. And he did a lot for Play Framework and Scala, but your background was Java before that, and I think mostly like Spring, if I remember correctly, and then into the world of Play Framework and Scala, and then we can talk about where from there. But it was so fun to work with you, and the reason why, the big reason why I wanted to have you on, you're amazing, of course, but the big reason is that you've gotten into Rust lately, and so and you always kind of say on Twitter to me that you should check out Rust. You're going to love Rust, all sorts of good things in Rust. And so I was like, we got to have you on to talk about Rust. And so, so that's really the impetus for it. Yeah. But I do want to hear kind of your journey through programming and to where you are now with Rust. And I'll give us some context, I think, to talk about, what you've learned and how that journey's gone.
Well, that's a great intro. Thanks so much. And I think you're very generous. So you mentioned then about when I joined TypeSafe, I was a Java programmer using Spring. Well, in fact, I worked at Spring Source under
that's right.
VMware, which is, of course, where I met Rod and Ben Alex and some amazing other people. And I joined Spring Source. I sought a position out there because I wanted to work with those two individuals in particular. And I learned a great deal. And so when I landed at TypeSafe, I think I was the only guy they'd hired who did not know Scala or SBT or, have been exposed to functional programming and so forth. I was a happy, and I sincerely mean this, a happy Java developer at that point.
Yeah.
And Spring was my world. And I recall the first 12 weeks or so of my time there at TypeSafe being completely lost, feeling like I knew absolutely nothing, and at that point I'd been programming for 30 years,
Right.
So
what's amazing is I felt the same way. It's like, even having known some Scala, I would ask for help to like Victor Kling or Josh Surratt, these brilliant people. And a lot of times it would just make me feel really dumb because I'm like what they're saying makes no sense at all to me because they're just way too brilliant for me. And so, it was a hard place to work for somebody at my, level of programming abilities.
Well, that was never apparent, James. Let me just say that first of all.
He's very good at that.
Hiding,
pretending to understand.
I just nod.
He's super good at it.
Yeah,
no, he'll get up in front of an audience and explain things that he doesn't fully understand.
And then get told that I don't know what I'm talking about.
Yeah.
I have this little running group. I'm into my running, and they love commenting on how I like to talk about shit that I don't know anything about. And it's something I'm very good at, and obviously that's what I'm doing here today with Rust. Naturally,
perfect.
How long have you been using Rust now?
How long?
Yeah.
Yeah, I've been using Rust probably. There was a bit of an on and off period. Rust, I guess, has been part of my world for the last 4 years, and I would say that in the last 1.5 to 2 years, I've been using it full time. Pretty much.
Okay, but before we get to the details on that, though, I do want to hear about your journey to functional programming, because while you were at TypeSafe, you actually did make the transition to Scala and functional programming. And I'm sure that your code reviews initially from Havoc Pennington, where he's this could be immutable, whatever, that was maybe part of the journey. But anyways, I want to hear about that journey to functional programming. And then, because I'm guessing that is in some ways related to Rust and how you use Rust and all that. But I want to hear it all.
It sort of is. And I think this actually touches on another interesting point that I'm just going to keep in the back of my head for a second. But I did not have any difficulty with adopting Scala as a language, I would say. And actually, I know, again, in some previous podcasts, we've talked about a variety of languages and so forth. I thought I'd count up the number of languages that I've used in anger. Over my 39 years it is since I've started programming now, and I've used 15 different programming languages in depth. Right.
Wow. Are you including like CSS and HTML and all those?
No, I don't include those languages. Yeah. No, I think
not SQL or regex. So if you expanded to, I don't know, those, I don't know, some people would call them programming languages, but anyways, languages, computer instruction languages.
He means real languages.
Real languages. Oh, I don't want to get in trouble for calling, I don't know, some of these things not real languages. But
we can boil programming down to the three things, right? Which is sequence, condition, and iteration, right? So languages that support those three constructs. If you want to include that, I mean, you could argue XSLT included that. I don't know if I had that on my list or not, but there's some esoteric ones in there. I actually did a bit of COBOL for a while, and that was fun. And then I did a strange language that Digital Equipment had called Dibol, which was, so COBOL, I think, had 5 or 6 different types of divisions in the code, and Dibol had 2. So it's a programmer's, the productive programmer's COBOL at the time. And I sort of, I did use a bit of Clojure. I've done a bit of Clojure, which I really enjoyed.
Is that the only Lisp on your list?
It is, yeah. Lisp was kind of in my world very, very early on, but it just kind of went over the top of me, as to what it was about it that I, is kind of useful, which I appreciate now, which of course is its expression orientation.
Right, you realize at some point, oh, that was actually good and brilliant. I just didn't have the frame of reference to appreciate it.
Same experience. I was using it with GNU Emacs, so I was using their Lisp, and it was just this kind of weird language but I didn't understand what I was doing, which now if I looked at it, I would have a much better idea of why things are the way they are.
Have you done any Clojure yourselves?
I've read some code, but it hasn't. Lisp syntax, I try and get away from things that are kind of machine oriented rather than human oriented. And I feel like Lisp falls into that category.
Yeah.
Well, actually, I think you're right. And I think it's one of those languages that are enjoyable to write code for, not so much reading code from, whereas Python is the opposite, right, in a sense, because it's designed for readability and certainly has achieved that goal. And Scala 3 also with its significant indentation. When Martin introduced that, I just thought he'd lost it. And we had a chat. We actually, a couple of years ago, we stayed with Martin. Our family stayed together in.
Oh, nice!
It's lovely. It's great to see him. He's a good friend still, and and we talked at length about that. And it kind of like all the light bulbs sort of came on as to why he actually did that. And I kind of feel it can be the next sort of Python, perhaps, in that regard. Because it has the same presentation.
We've been using that syntax for our Scala 3 ZO book, and I've just fallen in love with the syntax. I'm like, this is so nice. It's really hard to go back to.
I obviously already liked
syntax.
It. So.
Being Python.
What are the most esoteric languages that you guys have used, though?
Oh, most esoteric. I've been pretty mainstream. Assembly was probably the only one that I would put in even near the realm of esoteric.
APL, when I was a physics student at Pomona College, they actually had an APL machine.
Yeah.
And
That-
APL was
it's short for A programming language. So
brilliant.
That should tell you everything.
Yeah.
It was everything was symbols. So it was really for mathematicians and physicists and everything. So you had to have a special keyboard, and at the time that was like custom made. You couldn't get a off the shelf keyboard. And so the machine and the keyboard and everything, and the keys, they had the del operator and the dots and the so you were manipulating matrices and
that's pretty esoteric.
Yeah, it was.
That's esoteric, definitely.
Yeah.
And
I think it was probably a functional language too. Now that I think about it, I mean, I'm pretty sure
designed for mathematicians, unlikely.
You want it to
well, that's just it. I mean, oftentimes, we use these things and then reflect on them and go, "Oh, hang on a second, that was functional, right?" You could put SQL into that category. You could, to a degree, you could put XSLT into that category, most certainly. And then later in life you go, oh, okay, hang on, I can pigeonhole it over there now, right?
Yeah, you start to see the matrix, like emerging. Yes. You're like, oh, now I see how this thing that I've now learned what it is actually in this place that was never described to me in that way. Which maybe with Rust we'll get into type classes, which would be one of those things where it's like, now that I understand type classes, I look at Rust and I'm like, oh, that's type classes. And very few people, I think, in Rust call them type classes. But anyhow, let's get to that.
It's not bandied around. Yeah, I think terminology often confuses the picture as well, But another case in point was all those years ago with the Gang of Four and the design patterns book. I remember when that came out, and reading it, and I loved it. I had it on my shelf for years. I've actually now finally, departed with that book. I think it's probably mostly lost its relevance to me. But at that time, it was wonderful to form a language through which we could communicate. And actually, you guys talked about, I think it was you guys talked about UML a while ago as well. And
I remember that. At one point we talked about UML and the attempts to take UML and run it, runnable UML. And, that was. And why don't we use UML for modeling anymore?
Well, actually, I kind of do still. Actually, I don't mind admitting that.
But didn't you, before UML was a thing too, didn't you draw boxes and arrows?
This is it. So what UML did was to unify that language, try and formalize it so that we could spend less time at the whiteboard dreaming how we should communicate this thing that I want to communicate to you.
Like you're saying with Gang of Four, like it gave us just a standard communication, like the common vernacular for talking about things or common diagramming. And as you said, it unified the modeling language.
Exactly.
Right, because you probably remember there was pitched battles between the box people and the cloud people.
Yep.
And that's the unification was that you had these two separate groups and they were arguing about whether they should use boxes or clouds. And whoever it was came along and said, we're going to hire all of you and that's going to unify this so we can move on.
Rational?
And we ended
was
up
that
rational. It was rational. Yeah. And then so we could move forward. And yes, boxes are obviously easier to draw. So, but boy, the cloud people were just really committed to clouds. That was the unification.
Was that Booch?
I think Grady Booch was the cloud proponent.
Oh, he was on the cloud side.
I could be wrong about that. I don't remember, but I mean, it was a whole kerfuffle, and now we don't even talk. It's like Y2K. The world is going to end. It's like, what was that thing again? I don't remember it. Except you were probably programming COBOL at the time.
Yeah, fixing COBOL.
Well, no, my COBOL days are a bit older than that. But I do recall getting a few contracts around Y2K, which were, they were nice to have at that time for sure.
Extremely lucrative, I would imagine.
Yeah, exactly. So that was kind of
kept
crazy.
The economy afloat.
Panic
kept the
was involved.
Developers fed for a while.
Actually, around
Yeah,
that
go ahead.
time, I just want to quickly interject. Around that time, I was programming C++ in Palm OS for the Palm Pilot. That was,
Oh, nice.
yeah,
Wow. Huh.
that was my
And
big.
that, in retrospect, you're like, it's no wonder that that device failed because the programming model was probably horrible.
Well, actually, not.
I guess maybe
No,
not worse than Objective C when iPhone got
I
programmability.
well, I do a lot of Objective C as well, right? So I'm bleeding out those 15 languages now that I've
Yeah.
organized. The Palm OS or the Palm Pilot, and then I mean, it went through a number of acquisitions. In the end, my take on it is that the company lost its way from a leadership perspective. Right, that was really what happened there. And do you know that Palm OS lives today in televisions?
Whoa,
So
that's
it's
terrifying.
yeah, I know. So I've got a couple of LG TVs, LED TVs, and they're running Palm OS.
Wow.
So
Wow.
it
They're still
lives.
making licensing royalties or something on Palm OS.
You know what? We
Somebody
should
is,
start
whoever,
talking about
some
Rust.
private equity.
Yeah. Okay.
Okay,
Sorry.
but I do want to hear, that's a fascinating side note. I do want to hear about your journey to functional programming in Scala, and because I think that kind of sets up some of the Rust stuff, maybe.
Yeah.
So,
Okay.
yes.
All right. So I want to say so. This is the thing that was in the back of my mind earlier that I'm putting to the foreground now, and that is that when thinking about functional programming and languages and so forth, I think it's really, really important to take that step back and think about why we do this, right? Why? So, for example, why functional programming in the first place?
Yeah.
And I just think this is often lost in the discussion.
Yeah.
And at least for me, it has always been about writing correct software, right?
Mm.
And having our tooling be able to assist us in so doing.
Yeah.
Now, functional programming is a way of doing that. I don't think it's the only way of doing that. And I think there are complementary ways of doing that as well. But that's fundamentally what it was about. And even before TypeSafe, where I got into Scala, I was, gosh, I've forgotten, what's the Google collection library that they have? Guava, right?
Guava. Yeah.
I was using Guava for some time in my Java world and
So you're doing some
having
immutability before Scala, and so you had some experience with
that's
that
right.
paradigm.
Exactly. Yeah. So, this notion of immutability wasn't at all foreign to me when I landed with Scala. When people started talking about monads and so forth, then I got a little bit lost, right? Because
Yeah.
I don't have that mathematical background. I don't think a lot of people do, right? And I think
You didn't do category theory in college.
yeah, well, that's it, and it just didn't seem kind of relevant to the conversation for me, right? But that's I think my goals in terms of what I do in terms of my career are at a higher level than that. In terms of I must be a functional programmer and so forth, right? It is I want to solve problems with computers, and I want to solve them in the most correct way that I can, while at the same time being practical about it too. We need to deliver these solutions. They need to get done. So I get more in a sense. I get more of a thrill talking about what it is that I've created with these things than I do necessarily about the journey. It's not to say I don't get excited about that journey at all, right? But I hope that's making some kind of sense, right? That I equate functional programming to an important tool towards software correctness.
Yeah. Yeah, no, it's good to come back to that, because I kind of define myself by being a functional programming zealot. And maybe you would more define yourself as being, I want programs that are correct, and maybe functional programming is a way to do it.
Yeah.
Yeah, I kind of came to that same conclusion myself after struggling around, because when people describe functional programming to you, they often fall into the details very quickly and
Yeah.
don't really ask the high level question, why are we, I mean, this is harder for me if I'm
Yeah.
coming from a, procedural object oriented kind of approach. Why am I going through all of this? And
Yeah.
unless you really make the case that, oh, we're trying to make, it's all about code correctness,
Yeah.
then
It really is. Yeah.
it's hard to
Yeah.
sell it if you don't stay on that message.
Yeah.
And,
Yeah.
and
Making it, I mean, this is what our podcast is about, is like, how do we make it easier to have better software? And to me, a big part of better software is more correct software that is like verifiably at compile time correct.
yeah, I mean, I think that's a big part of it too, right? That leans back on that statement I made where we're falling back on our tool chains to support us in this.
Yeah, I
So,
wouldn't necessarily. I mean, I think that's also falling into a detail. Um, I think verifiably correct, some of that happens at compile time, but then sometimes there's runtime stuff too,
Yeah.
So it's like
Correctness
is
any
the
integration
goal.
Can't be verified by a compiler.
Mm-hmm. There's some things that
there will always
or,
be there will always be bugs, right? We're always going to have these bugs, no
There will
matter.
always be integrations. Like, what program doesn't have an integration with
Yeah.
something?
I think an important thing there to consider perhaps then is how we can also get into production with more confidence, because when we deploy to production, then we begin to learn, right? Then we begin to understand what the flaws of our assumptions are. So we can write software correctly to our assumptions, but then we discover that our assumptions are not always correct. Right. So we need to.
I had no idea the user was going to put that in that input field.
Yeah, exactly. Yeah. So I've recently deployed a service into production. It's a little Rust-based service. Surprise, surprise. It actually integrates with some JVM services and so forth. And very happy with it, and deployed it, got it into production, and so far, I think I'm down to 4 production bugs, that I've observed through metrics, in terms of it not behaving as to my assumptions at that point, right?
Yeah.
So even with what I would call good tooling, it's not the end deal, right? So I don't think that there's, I think it's not worth chasing that goal. Yeah, I don't think you can get that bug-free sort of software goal. That would be silly, right? But it can help. It can help a lot, and I think that the more time,
how do you have more confidence, less risk, and do it with less effort than probably NASA puts into having confidence that their rovers are going to work when they land on Mars. Because that takes a lot of effort.
It does take a lot, but look at the way SpaceX do things, right? They. Sorry, you're going to get me onto rocketry now. I love
that sounds fun.
I love what SpaceX are doing, of course. I love what NASA are doing. I love what everyone's doing in space. But they have that culture of failing fast, right?
Yeah.
And that doesn't mean to say they're doing it wrong or anything like that, but some of those assumptions they're making are you just don't know until you actually do it, right? And and it's the same with the first lunar landing. They'd never done that before. They discovered a whole lot of stuff.
They learned some things, yeah.
They did learn some stuff, and I love to talk about how the guidance system became overloaded and still managed to stay up. I mean, we talk about resiliency, that thing was amazing, the thought that went into that, back then, but they still learn, right? And of course, that's always going to be the case, but,
having feedback loops. And sometimes your feedback loops are very close to you, the compiler. And sometimes your feedback loops are further away, like in production, and sometimes they're really far away, like in Mars. But
Yeah.
hopefully, you have good feedback loops, no matter what how far away they are.
Yeah, yeah,
And compile errors in Rust. We should probably just move to Rust because it keeps coming up. Compile errors to me are one of those things where it's giving you really good feedback right away and makes such a huge difference. But so, anyways, let's go to Rust. Like, how did you get to Rust and why?
Well, let's start with the why again.
Yeah.
Because I think that again is crucial. I see tweets about Scala developers going to Rust and so forth, and then complaining that it's not Scala and that kind of stuff. And I never had that issue. So for me, I have this massive bent on energy efficiency, right? I have
because of the domain that you're working in, or just like you're concerned about the climate, or
yeah. So it came from the climate originally, and in fact, actually, one of the reasons I left TypeSafe stroke Lightband was because I was having a great time there, right? And it was a great job, great people, and I was very concerned about my skiing career if I'd left. I'd have nowhere to ski around the planet. So, lots of difficult decision making, but it came down to it for me personally. It didn't feel relevant anymore because, well, no one around me could understand what it was that I did, and my kids couldn't understand. And this kind of bothered me a little bit, right? So, I remember my son being asked. I'll get onto Rust in a minute, I promise. But I remember my son being asked at school, they all went around the class saying, "What do your parents do for a living?" and all that kind of stuff. And one kid gets up, "My dad's a builder, my mum's a teacher," and got to Hugo, my oldest boy, and he goes, "My dad's a nerd." Right. That's all you could sort of use to describe.
He didn't say, "Oh, he builds actor systems for build tools that take web resources and process them into a pipeline." That wasn't his answer.
He knows you're a computer programmer, right?
He does know I'm a computer programmer. I did
so
sort of put
it in that.
Well, you could, but I think it's. I just got to the point in my life where I just felt that I wanted to make some meaningful contribution back somehow, right? Something important, right? So at that point, I decided, not
Did you
knowing
stare into the abyss? Is that what happened? And the abyss stared back?
It wasn't quite an abyss. I think I was looking at the ocean at the time.
Sounds existential.
Yeah. And I made a decision, not knowing how I was going to do this, that I was going to move into the domains of agriculture or energy or both somehow. And I didn't know what the next move was, but I left Lightband at that point, not knowing what my next move was. And then in the course of that, I ended up doing a gig with Cisco. And it was a great gig, actually, where they effectively kickstarted my company now, Titan Class. They invested in us originally, and we developed this platform for agricultural IoT. And this platform ran at the edge, and it also had to run in a very energy efficient way. It was a single atom processor with a gig of RAM, and so we had barely a core to work with, and we squeezed the JVM into that environment, and we managed to get it to the point of having, I think we ran about 6 or 7 in quotes microservices running in about 500 meg of RAM. So we really squeeze things down. There's some tools and techniques that you can use to do that. And this is before Grail VM as well. So I have a project, it's still there, called Landlord, if you're interested in looking at all, but it's at the end of the day, it was just all too hard. And we made the decision to use the JVM for that platform for Cisco at that time because it was proven technology, given ACA and so forth. It had strong communities associated with it, and that was the focus, right? It's like, how do we build and promote a platform? We don't go and reinvent the wheel. We basically consolidate what's out there and leverage the existing communities. So that was the focus of that.
And at the time, Rust was probably pretty early. So you maybe could have done Go, but...
Yeah, true. Well, actually, we did end up writing some Rust for that platform. But that did come a little bit later. Again, I think the reasons that we had were good reasons. We made the right decisions at that point in time, but it was hard. It was really, really hard work. And so, it became obvious quickly that if we wanted to do stuff at the edge, then we would have to go beyond the JVM. Right.
When you say at the edge, you're talking about on these like very constrained devices that are, doing a bunch of sensor stuff, whatever. And
yeah. And this was kind of difficult for me because I loved and I still love Scala, right? But I had this incredible emotional bond to it, which I think is problematic in our industry, that we form these attachments to technology. And, at the end of the day, my feeling is that it holds us back more than anything else, I think
that's part of our identity. Like I definitely feel like the programming languages that I've worked with, I've identified myself by them and as part of those communities, and it definitely frames then how I see other technologies.
So you could have moved to C++, right? For this project.
I did a lot of C++. I've done a lot of C++ in my time. If I look back over all of my years of programming, I've probably done the majority of it in C++.
Okay, so why wasn't that an option?
Well, I mean, obviously, it didn't satisfy those original decisions that we sort of made, and what I found also with the Rust community very, very early on was that it was very welcoming, and this is a huge thing. I think when looking to adopt any open source technology, you're looking at some library or whatever you want to use, you're looking for some activity around it as well. You want to see some engagement there it depends obviously on what it is, naturally, but that's always been important to me. And and I have to add as well, so Jason Longshore, who was my colleague at the time there, he introduced me to Rust as well, right? So
mentoring or some help along the way into that world.
Yeah, definitely. Yeah. And, I think that, what I said earlier, as a happy Java developer, I was never really a happy C++ programmer, to be honest with you. I'm not trying to, diss C++ here at all. I don't want to diss anything, right? Because I think there's a lot of goodness out there in everything. But I remember, with C++, you had the laws of the big three. If you had a virtual destructor, then you had to have a virtual. I can't remember what the laws are now.
No, I don't either. I used to have it just right at my fingertips.
But, I know.
Operator overloading. You had to deal with the stack and the heap and all that kind of stuff. Yeah. But now that initially, when I look at Rust, it has very nice readable syntax, etc. But the idea of being, as James puts it, a human garbage collector makes me feel like I'm stuck in that same world as in the fiddly stuff in C++.
That's interesting, isn't it? Yeah. So my view on that is a while ago, I keep reflecting on the past here, of course, we had Corba. Remember Corba?
Yes, I do.
Yeah, okay. So Corba was originally built, I think, on top of Sun RPC. And I remember seeing the first time I used when I was a C developer quite a lot. I saw Sun RPC and I thought, wow, this is amazing. You know, I can abstract out of the network and not think about it. How good is that, right? And then over time, we eventually realized that was a mistake. That it was actually important to recognize that you're dealing with a network. When it comes to memory, I feel the same way. That you should not feel comfortable in handing that management of memory to something else. This actually takes us down a bit of a wobbly path around my feelings on garbage collection, right? And I controversially thought for some time that we might ultimately recognize that as a mistake also. Because it's empowering to be able to manage memory, not to the degree that we do with C, you know, where we have to, we can really shoot ourselves in the foot, right? The compiler's not doing a great deal to help you remember that you must freeze something necessarily. But languages like Rust really do take care of that problem for you. Right, it's able to bring memory management to the foreground again, but not make it a pain to deal with.
Yeah,
and
at least a programming model around it, which is better than having to be 100% responsible for allocation and deallocation.
Mm-hmm.
Yeah. So it helps prevent you from shooting yourself in the foot. And I don't want to say that it eliminates that, right? Because you can certainly still do bad things.
Did you ever struggle with learning the borrow checker stuff, or
no?
So it came pretty easily.
Yeah, it came pretty easily. And a lot of people talk about the borrow checker when they talk about Rust. And you're going to have to get used to the borrow checker, and ownership and that kind of stuff. And honestly, that wasn't an issue. Perhaps what was really foreign to me that has taken some time and effort to deal with are the concepts of lifetimes. So you have lifetimes as a concept in Rust as well, which apparently, if you are a developer of a compiler, you're used to this sort of stuff. But it's brought lifetimes to the foreground also, and that has a few rough edges on it. That takes some effort, I think, to grapple. Right. But again, I think that, and I've probably just done this myself, I've sort of made it sound worse than what it actually is. In summary, though, I think that managing memory makes you aware of memory. And being aware of memory, it's like, in your home, if you're aware of the power that you're consuming at that point in time, you'll probably consume less. Okay, so there's a great advantage in being aware. I don't like how in our industry we just keep burying things, in layers and layers and layers. I think that actually leads to problems. So I get a concrete, hopefully a concrete example is on the JVM. Whenever you want to optimize something, you actually end up working around a garbage collector. Yeah. Right? And you go, well, hang on.
Unsafe, yeah.
What's the point of this?
Land and start managing memory on your own is what happens inside of Netty and other tools, Akka, and yeah. So they're like, let's get around the memory management that the JVM is giving to me to optimize this.
Yeah. Let's start doing things off the heap and, so we have a little more control again. Well, how about we just make memory management first-class concern again, but we'll make it easier for you to deal with, right? And that's the thrust of it with Rust is my take on it,
Yeah. So given all your languages and Rust being your number 15th or something around there, what were the things that were hard? What are other things that were hard or easy or surprising in the language that you encountered?
Yeah. So async, so Bruce, I know this is I can see your ears pricking up. No one else can, of course, but maybe they can hear them pricking up or whatever. But async await in Rust is both a beautiful thing and also has rough edges. Okay, so I found myself quickly getting myself into situations where, what do you mean I can't have the async keyword on a trait defined method? For example, that's currently not permitted, and it's a natural thing that you want to express, and there are workarounds for that, but it's just something that the language currently doesn't support. So, async await is a work in progress. And it's not completely there, but by God, it's usable, right? And it works incredibly well. And so one of the fun things, I do a lot of embedded programming as well on the metal, which I love because, all problems tend to become my own problems rather than any other layer between me and the processor. So I do quite enjoy that. And I'm using a framework, a Rust framework called Embassy, which is a async executor for on the metal devices. And we're dealing here with chips that have a single core, very limited resources, and we can use async await in that context. And the beautiful thing about this and why it's important, right, to come back to the why is concurrency important, right? Is because it assists with energy efficiency, right? This is the big why. So we could be blocked waiting on reading from, the serial port on the UART, for example, but still able to go and do other things. Other tasks can progress and keep that processor core running and hot. Not physically hot, right? But just run. Processors are good when they're running. They're not good at idling. I mean, if you idle, they take time to start up and do their thing and so forth. So you want to keep them warm when you're doing stuff. So the more warm you can keep them, the more things you can throw at a processor at one time, then the more efficient they are. And then in my world in particular, where some things are running off a watch battery, your batteries are lasting a year or 2 years or 3 years, right? And it makes a big difference. So earlier,
so it's like you want to do as much in parallel or whatever as you can, so that then you get it all done, and then the processor can go into idle for a while. And then when it has work to do, let's get as much done all at once as possible. And
so
then
you're
go back
saying
into
when
idle.
the processor is not idling, it's using roughly the same amount of energy? And so you might as well get as much done rather than having it
it's like you've put it into the higher power states, whatever. Mm-hmm. And so you might as well maximize that capacity at that time, rather than sequentially building up a bunch of tasks, which are all going to keep the CPU running and running for a longer amount of time.
That's exactly it, right? And I just want to pick you up on one word: parallel. It's not parallel, it's concurrent, right? And again, we're dealing with single cores here, and people, it takes some time to understand that distinction between being concurrent and parallel. I think the work that's being done on the JVM now with continuations and so forth, with its async await sort of approach, is to me more about concurrency than parallelism. And that's a good thing. It's a very, very good thing because it leads to the same sort of outcome. So here's my sort of mad focus, and maybe listeners will go, well, you're running embedded stuff, that you got to think about that all the time. But you know what? You write services in this way, for small resource constrained environments. And when you get to write services for, environments with seemingly infinite resources, which is a myth, because they're all finite, then things tend to run extremely well, right? So when I deploy to a new farm or something like that, then I can choose the smallest virtual CPU on offer by my data center. and that there's an economic
You feel
benefit.
good about that you've not had to scale up to this massive machine to
Yeah.
handle a workload that you could do the same work with a lot less resources, and that feels good.
I
Saves
can't get a
money.
machine. I can't get a machine with my current retailer of machines. That's less than 1 gig of memory. I don't even need a gig. Give me like half a gig of RAM or less, or 256 meg of RAM. That's just give me one of those. But you can understand here what the environmental impacts of that are too, right? We need then less. Our data centers don't need to be as big. I'm sorry, James, this is a terrible idea from a Google's perspective, right? But
I'm not on Google Cloud anymore, so
but we can make our data centers small again, right? And really, I could go on about how we have to improve the way we produce energy on the planet and so forth. But food reduction, we generate far more food than what we actually need on this planet right now. I know there is starvation in some countries and it's disproportionate and so forth, but countries like the US and Australia, I know here we generate 3 times the amount of food that we need to. So the point is that there's a lot we can do also about becoming more efficient in what we do. And I think that in our world, we have a responsibility of also running our programs more efficiently. Right. And we should stop and think about the memory that we're using and the CPU that we're utilizing and all those things, right? So that we can have this positive impact into our world. So there you go. I'm going to get off my soapbox here a little bit now, but that's what's driving me a great deal. There are other benefits when you get into the embedded world of we mentioned battery efficiency, of course, but heat is the destroyer of circuits, right? Of boards. So if you can run cool, even when you're maxing out your activities, then your products, your components will last a great deal longer as well. So there are actually some real strong economic drivers that you sort of you benefit from here as well.
Yeah.
Yeah. So we've really not about Rust, have we?
Yeah. No. So a lot of your why is on the efficiency side of things, and that makes sense. What about the efficiency of your time? How do you feel developer productivity has changed as you've gone into Rust compared to other languages?
Gee, that's a good question, because there's a lot of argument. I think also there has been a lot of argument in the past with Scala and other languages, not being as productive, But I think that is just largely a function of how much time you spend with a given language and its tool chain. I mean, all of these things.
Library ecosystem and some of that too.
I think
Compile times. How long do you spend between cycles?
Yeah, I see people complain about compile times with Rust, and I'm thinking I kind of don't understand that. Yes, we'd all like everything to be instant, but it's you compare that with this compile times of a lot of JVM stuff, right? It's a lot faster than that. So I find that I'm very productive, and on occasion I do have to go back into the JVM world and so forth. So I get to make these direct comparisons, and I think the Rust story is very, very good in terms of its tool chain and so forth.
When you hear a lot about Rust's error messages, compile error messages as being extremely helpful, and that probably saves a lot of time. It's like, oh, okay, that's what I need to do here.
What Rust error messages tend to do, and this is ongoing work, but what they tend to do is tell you what the problem is, right, and then they tell you how to fix it. In the same error message.
It's very instructive in terms of what it thinks you should do to fix it.
Yeah, and again, it's not perfect, right, by a long shot. I'm not trying to paint that picture here, but that is definitely the goal of the activity in that regard, to keep those messages to be helpful. And there's a tool that has to be part of everyone's tool belt when using Rust, called Clippy. Okay, and Clippy is a bit of a linter, right? And it just goes through, it'll point out a lot of stuff the compiler won't. But you get it, in the Rust tool chain itself. And when learning Rust, I mean, when learning Rust in particular, it's fabulous. It really is kind of representative of, well, Microsoft Clippy wasn't that great, I suppose, was it? But it was
There's
trying
a
to
play
be
on
good.
that, but it's actually good. It's actually helpful.
Well, yeah, it is. It's incredibly helpful, right? And I think that's probably like the number one tool. I've actually brought people onto projects, several people now onto projects that have never used Rust before, and I've been here to sort of help them through that. And none of them have had any problem at all. One was a guy that had only ever done TypeScript, nothing else, right? Another guy. A lady, I should say, she had only done she'd done some C++, but she mostly did Python, and we were doing a machine learning based project actually with that one, and I gave her this task to write this little engine, and she did that in and I said, look, do it in Rust, give it a go, see what you think. And anyway, she got through that, no problem at all. And then, a current colleague of mine, Scala background, has had no issues either. And maybe it's because I'm around and, we can sort of help each other a little bit. But, we've used actually, if I could just explain where I've used Rust. So I mentioned embedded already. So there's been a lot of embedded work, which is good. We have these electric vehicle chargers that we're building right now. It's kind of cool. It's a whole different conversation maybe, but our programs on there, the whole EV charger is 120K in size, and it's just, we're back to that. We're back to sort of the size of C programs, not C++. It's even, it outperforms C++ in this regard.
Very constrained. Yeah.
Yeah. So that's nice, but my services on embedded Linux devices are around about 8 to 10K of memory in total, but these are full blown microservices doing Kafka-like kind of things, but, not really Kafka. So, you've got those efficiencies, but so I'm using it for backend services. And I know this came up, I think it was last week, right? WebAssembly. So Rust is probably one of the best languages to use on a WebAssembly target right now. So I've deployed 3 applications to production using Rust and WebAssembly, and using a web framework called U, as in YEW, and which is very React-like, but all written in Rust and WebAssembly. And
it's been an enjoyable experience.
Yeah,
you feel productive, and WASM is obviously fast, or at least theoretically fast, and
again, for me, it's about correctness. I just if I probably will diss JavaScript here a little bit now, but if there's not one language I never want to use again, it's probably going to be that one. And it's completely
too many foot guns. Too many foot guns in JavaScript.
Yeah. And me, James, when back at TypeSafe, I was pretty big on JavaScript. Do you still maintain WebJars today?
Oh yeah. Yep. Still maintaining WebJars. Yep.
There you go.
It's the ball and chain, don't ever do open source. Don't ever do successful open source, because then it just becomes takes all your free time.
And then you had Josh on a few weeks ago, which I also really enjoyed. I love
about build tools. Speaking of that, I want to hear your take on Cargo, because you've used many build tools, and I hear really good things about Cargo. Is it really good, and why?
Is it really good? Yes, is the answer to that. Why? Oh gosh. So because I think it allows you to do the simple things simply, and the difficult things can still be done, right? I think that's the essence of a build tool, is it not? Right, where you do not want to invest your time into understanding the build tool. You really just, you really want the most.
Yeah. As software engineers, we generally don't want to be build engineers.
We don't. I mean, gosh, it's, we've got enough things to do, haven't we? Really, it's like, why do I? It's kind of like having to know the internals of Postgres to use it. I mean, why would you want to do that, right?
Yeah.
So I think that if that sweet spot is really just expressing the bare minimum, which is quite declarative in TOML file format. You're in essence just describing the targets that you intend to build for and your dependencies, your development dependencies.
So it's like make.
Like make. Well, I use a lot of make as well. I think it's a lot simpler than make even. The thing is with make is it very quickly becomes complex. Don't you think?
Oh yeah.
Yeah.
Kind of hit the wall and then
because
have to.
They tried to only solve the really simple problem, and then they had to start adding stuff on to solve the more complicated things. And so it sounds like Cargo was designed like from top to bottom all at once. And so
to give you a progression.
Yeah.
It's progressive experience. We have to acknowledge here that Rust and Cargo and the other associated components of the tool chain have all had the benefit of everything that's come before it, right? These things have not been invented in a vacuum. I think actually, if you, sorry, just to quickly jump back onto the language for a second, but if you're a Scala developer going to Rust, I think you see a lot of familiar things, really.
Yeah.
And as you do with other languages too. So it's not been developed in a vacuum, and in its current communities, I think,
well, you say that, and yet, there are languages that should benefit from all the languages that come before them, but choose not to.
Mm-hmm. Yes.
So it's quite a good choice to really study all the languages that came before and learn from them. So I appreciate that.
Yeah. Well, also, I think Rust fits into that category of being a derivative of ML, right? I think it's in that same family tree, which is, Bruce, I know to your heart is, I know you're fond of expression-oriented languages. It is an expression-oriented language. Albeit with a very sensitive, touchy topic coming up, it does have semicolons. Oh my God. Yeah. But, I know how you feel about this, but because I've been listening. Right. But
it sounds like something I would use. I have done an experiment with it using with a friend where we created a Python extension using the Rust. I think it's called Pyodide or Pyo3 or something like that. Yeah. And it was just marvelously put together. And if I was to need to write a Python extension, I believe I would use Rust for that.
Okay.
Yeah. Despite the semicolons, at least it's expression oriented, which maybe
I can live with the semicolons. I'm always disappointed if a new language chooses to use semicolons. It's too bad.
Yeah.
But I can live with it when it gives you a lot of other good stuff.
Yeah. It's just, it's one knock against it, but there's so many other good things in Rust that outweigh it, like expression oriented, type classes, which
you got to know, again, I think it's important to understand your why you're using it, right? Because that will often trump the semicolon.
Sure.
Yeah.
Oh yeah.
You mean you don't choose your language purely based on whether or not it has semicolons? That's not the motivating factor.
I find lack of semicolons encouraging, for sure.
Yeah.
It means the compiler writer isn't just thinking about themselves. They're thinking about me.
We want unselfish compiler authors. Yeah.
Well, I again, I was torn, having to make the decision of leaving the JVM number one for I think hopefully I've conveyed why. But also Scala as well. I'm still fond of it. I'm still fond of the language. And, the semicolon thing used to really irritate me as well. But again, my other goals have sort of trumped it a little bit. I
Yeah.
can't say the word Trump in the US. Sorry, I do apologize.
We don't use that word.
Yeah, I guess there's
Yeah.
just always trade-offs that we make, and I just saw somebody on Twitter saying how in Rust they really missed the Scala standard library because the Scala standard library is so expansive and so many collection operations, and anything you want to do in a collection, there's this high-level function for and in Scala, and so they missed the expansiveness of the Scala standard library in Rust. So, but there's just trade-offs, right? Like you take
Yeah.
some baggage with that large standard library.
You do. Actually, I saw that tweet also, and I know who it is. I think that may also come into the category of trees trying to look at Rust as being Scala. It's not. Okay, just as Scala is not Haskell, right? But look at the friction that has caused, in the past as well.
Yeah.
So I think that you've got to, again, go into it with eyes wide open and just, be prepared to, start over on a few concepts again, perhaps, because I don't find the standard library limiting in any way. Not really.
Yeah.
I just wouldn't be getting
for what you're trying to accomplish. It's sufficient.
Yeah. And but having said that, the Scala standard library is beautiful. It's beautifully thought out and evolved, and I don't want to take anything away from that either. But I wouldn't try to. I've seen some attempts at retrofitting the Scala library into Rust, and just not being received, like immutable collections, for example. I'd not seen as being important. And one important thing about Rust is that it's not what I would call a functional language at all. It has immutability by default, sure, but the important point is that you can reason about its imperativeness. That's the important point. And why we are attracted to functional programming is so we can reason about our code. Okay. So it's found a way, I feel, that you can reason about being imperative. And being imperative is very useful at times, as is the case also with the implementation of parts of the Scala standard library.
Yeah.
So
Russ, reasonably imperative should be the tagline.
So here's a weird out left field question. Does Rust have a yield keyword, or does it support the idea of generators?
Yeah, this is a work in progress.
Oh, they're thinking about it.
Oh, they're more than thinking about it. So Rust has a incredibly powerful macro system. Mm-hmm. And you can already, using the async, I think it's just, no, hang on. No, it's called the stream macro in Tokyo, which is one of the popular executors for Rust. You can already use the yield keyword in there. So you can indeed create generators. I believe that in the standard library, we have a type called, we have a trait called future. We also had one called stream, and that has been renamed now to, I think, async iterator, I think. And the purpose of that is to move it towards being able to introduce the yield keyword, right? But if you use the stream macro today, and I am, you can use the yield keyword in there, because you can actually invent your own bits of language if you want.
So I had this middle of the night thought that a generator or a queue is a degenerate case of a generator. So you put things in, you get things out.
Mm-hmm.
And the queue is like, well, you don't transform it in the interim. Is that, am I crazy to say that, or am I onto something?
Might have to sleep on that longer.
Anyway, maybe you'll wake up in the middle of the night now going, oh, yeah, I see what you're saying.
Yeah, I'm going to just ponder that one, if I may.
Please.
Yeah.
I'd be curious.
Yeah.
Because this was just one of those things that popped into my head while I'm thinking about all this concurrency stuff. And
async await plus what we're talking about here with generators. Really, again, the outcome of all of that is that you can write really nice code, right? Without, you can look at that piece of code and again reason about what's going on fairly quickly, rather than jumping about bits of code and trying to infer what's happening there. So that's what they're bringing to the table, and you can do that today with Rust. But I don't again want to paint the picture that this is a finished and polished aspect of Rust. It is definitely work in progress, and sometimes the reason things take so long is because there's a lot of thinking to be done on how to do it, and they want to do it really well. I feel so.
Well,
I think
in Python it took them 3 times to get it right.
Right.
Lots of iteration.
Yeah. So. And but it's nice, isn't it? I've used generators in Python in the past as well, right?
Very elegant.
So it's very elegant, yeah. So there's definitely I also thought I would really miss, and maybe I do, Akka streams. I know you guys are into ZIO. I guess I've sort of departed from the JVM, so I've heard very good things said about ZIO. But it's a nice way to program, isn't it? Right?
Yeah.
Being
able stream-oriented programming.
Yeah.
Akka streams and Zio streams are pretty similar in terms of the kind of developer experience of doing transforms on a stream, and so many different ways you can do the transforms. But
yeah,
that is a nice programming model when you have a stream and need to convert it to another stream.
Yeah. So I think there's perhaps a bit of growth there to be had on the Rust side of the fence, to sort of get that experience. But it's not. But having said that, it's not something that I feel is so missing that I've had to go and do something about it necessarily, right?
Yeah.
So
sure.
But I do appreciate it for sure. Yeah.
Any closing thoughts on Rust? I think for me, if I'm going to mess with it, I think I'm going to do it with you. Was the name of the web WASM framework you said? Is that right?
Yeah.
Seems like a good way for me to get into it.
Yeah, and you can also do it with me, as in me.
That's right. So, with you and with you.
Yeah, exactly. I think it is a good way of getting into it. There's a lovely tool also called Trunk, which you can basically write HTML, CSS, and .rs code and use Trunk, and there's not a line of JavaScript going on at all. Right. In the
I think Bottle. I don't know if you know Bottle, but I think Bottle has done a bunch of work in that area, and I see a number of tweets about being able to build a full-on web app and only write Rust, and that seems compelling to me because I don't want to touch HTML or CSS or JavaScript or any of those other things.
Yeah, I don't actually have a problem with HTML and CSS. I mean, I do have a general sort of comment, that we've bent a document-oriented model to run applications. I think that could be improved, and we've tried to improve that over the years with Mozilla's XUL and other approaches. Android uses XML, of course, to express its UI and has done so successfully. So.
Well, now that Compose is the new Kotlin-based model, but anyways, that's a conversation for another day.
Yeah. I just quickly, I did enjoy my Android development. I mean, during the pandemic, I kind of just said yes to everything, because why not? And so I ended up developing an Android tablet-based app that obviously was developed in Kotlin. I loved its coroutines and doing stuff there with its coroutines as well. And that was a good experience. And I thought the out-of-box developer experience, the whole Android Studio thing was really good. I thought
Nice.
they did a really good job. And I didn't have to spend a lot of time in Gradle, understanding Gradle, because I'm not a Gradle expert at all, right?
Nobody is.
You guys were talking about Gradle the other way too, but I didn't have to spend a lot of time there, other than adding the occasional dependency. So I got lucky.
Did you see, on a side note, I just happened to see this, that the Android native development kit now has Rust support. So if you do want to go back, I'd like to hear your comparison between the Kotlin experience and then you doing Rust for Android, if you ever get around to trying that.
It's just back in. So how with Android you can develop native code using C++. They've got a toolkit for that.
Yeah.
That's what That's what they've also supported using Rust, not the UI component, right? So UI component you're still doing in Kotlin and stuff. I saw a GitHub issue with a whole raft of dot points of this is what needs to be done to get to that point. So obviously they're thinking about it. I think that would be very, very interesting, and I know people that have used Rust on iOS with great success as well. I personally used to write apps that would be front-ended with Objective-C, for example, but then have a common C++ library. So you could definitely do that right now with Rust if you wanted to. So, but I thought the Android developer experience was good, but I didn't finish telling you what the app was.
That's right.
Yeah. So it was for hospitals, right? Because we all wanted to do something. And it used machine learning face detection to understand that when someone was in front of a basin, right, washing their hands, and it would face detect them looking down and doing all sorts of gestures to then guide them through the hand washing process, right? And then record compliance, because you've got to be there for like 20 seconds, and this is in a hospital. So, you wash your hands properly, in certain ways. So it played a video of how you should do that. Not that, doctors and nurses, they've got a pretty good idea already. But what was interesting was, 20 seconds in your head is not 20 seconds, right? And so this thing recorded that compliance, and it was a very interesting project. And it got deployed to a couple of hospitals and schools. That was Kotlin and Android.
That's a fun project.
It was good. Yeah.
It's a good COVID project to do.
Yeah. I've got some good ones.
Nice.
Well, electric vehicle chargers now. That's my current thing. But anyway, maybe that's a conversation.
Oh, the electric car chargers. Yeah. That sounds fun.
Yeah, that's fun as well. Yeah. But,
embedded programming it's really fun. There's something cool about being able to control hardware at that level.
Yeah. And very finicky as well. That's where I started. So,
right.
But I was doing assembly language embedded programming and some C. So like logic analyzers to see if your software was working right.
Yeah.
It's cool to be close
you
to
mentioned also that you studied physics as well, Bruce. Is that right?
As an undergraduate, physics, and then morphed into engineering.
Ah, right. I was going to say, I mean, some of the best programmers I know on the planet have a physics background, right?
I agree. Some of the other best programmers I know. I don't know where I fit myself, but I've just seen physicists in particular just seem to pick. Maybe it's because we're used to struggling with hard problems.
Yeah. Mark Hara, who created SBT, he has a physics background. Well, Mark Fleury, who founder of JBoss, has a physics background.
Mm-hmm.
Those are
Jason Van Zyl, who created Maven.
Van Zyl, JVZ.
Yeah. So they're all physicists. Yeah, what's I was so excited earlier this year. My eldest daughter left school and she went to go and study physics at uni, right? And I was so excited. I thought, right, she's going to become a programmer. But no, I don't think that's going to happen.
That's awesome.
Yeah.
Well, Christopher, thank you so much for sharing your journey and wisdom with us, and definitely gives me some encouragement to try Rust and learn it and learn from it. So thanks for sharing.
Oh, well, thank you. It's been so lovely to. Well, I can see you both, which is great.
Yeah.
But just to sort of catch up, and it's such a privilege to be on this podcast as well. So I really appreciate that.
It's fun to chat.
Think, I just want us to say, stay curious. Anything I've said, there's nothing perfect about what I'm suggesting here at all, right? Or talking about. But staying curious is what our good friend Jonas would always say, right? Jonas Benet.
Yeah.
Stay curious, and that's where it's at.
Yeah, nice. Let's do that. Thanks.
Right. No worries. Good to talk.